Welcome back to STS. In today's video, we're going to derive the inverse function of a rational function. All right, let's begin with the function f of x is equal to the quantity x raised to the third power minus 4 divided by x to the third power plus 7. All right, our first step is going to change the f of x notation into the variable y. So here I have y is equal to x to the third minus 4 over x to the third plus 7. Second step is to swap those x and y values, or x and y variables. So this y becomes an x, and these x's here actually become y's. Alright, my third step here is going to be to solve for y. In doing so, I notice that I can cross multiply. So first I'm going to multiply x times this quantity here, leaving me with x times y to the third plus 7 is equal to, and then 1 times this quantity leaves me with y to the third minus 4. Next I'm going to distribute this x to both of these terms. So this here becomes xy to the third plus 7x is equal to y to the third minus 4. Now I need to group my x's to one side. I need to group my y's to one side. So any term that has a y should be, I'm going to move to the left, and the terms that have x, I'm going to move to the right. So here I'm going to end up subtracting a 7x from both sides. Alright, these 7x's cancel because one is positive and one is negative. Here I have xy to the third is equal to y to the third minus 4 minus 7x. Matter of fact, let me rewrite this here at the top so everything's together as I continue. So that's x y to the third is equal to y to the third minus 4 minus 7x. Now I want to move this y to the third term to the left, so I'm going to subtract it from both sides. So minus y to the third and minus y to the third. These y to the thirds cancel, and here I'm left with x y to the third minus y to the third is equal to negative 4 minus 7x. Here I notice on the left hand side of the equal sign I have a common factor of y to the third. So let's pull out the y to the third. So let's undo that. Here I pull out the y to the third, and I'm left with x minus 1 is equal to negative 4 minus 7x. And now to get this y to the third by itself, I'm going to divide both sides by the quantity x minus 1. In doing so, these x minus 1's cancel, leaving me with y to the third is equal to negative 4 minus 7x as the quantity in the numerator divided by the x minus 1 in the denominator. Alright, now I see I have y to the third, but I really want it to just be y. So I'm going to take the cube root of the left hand side and the cube root of the right hand side. The cube root of y to the third is just y, and then I'm going to rewrite everything here to the left because that can't be simplified anymore. So negative 4 minus 7x over the x minus 1. So this here is in fact the inverse of the original function, and really I probably should also wrote this here as in this f notation showing the negative one for the inverse. Alright, at this point I want to go ahead now and switch to the calculator so we can see what's going on there. If you notice in the calculator, I have in position y1 I have the symmetrical line, which is y equals x. In y sub 2 I have the original function, and in y sub 3 I have the inverse. All right, what we're going to do is prove that this is correct, and we're going to do this in this fashion. The check would be the original function, which is going to be y sub 2. Oops, let's put this here, y sub 2, which is the original function, and the inverse is y sub 3, and I'm going to pick some value for x. Let's just say the value is 100. I know that when I evaluate that, the output should also be 100. If I do that in reverse, where I'm going to take the inverse and make the input the original function. And again, if I put in a value of say 25, that output should also be 25. So here we're going to prove that using the calculator. So let's go back to the calc. All right, so we've got our two equations already in place. Let's graph them to take a look. Here in the graph, the blue is that line of symmetry. The red here is our original function. And then the black here is the inverse. And you're going to notice that once these are all drawn in, that the black and the red are going to be symmetrical with respect to that blue line. All right, let's zoom in so we can get just a better look at what's going on here. Let's go to just number 2 for a regular zoom here on the middle. All right, and there that is coming in, the symmetrical line, the original equation, and then soon in black we're going to see the inverse. Again, we see everything is symmetrical to that, or is symmetric to that blue line. All right, now let's go ahead and quit out of this and let's go to the home screen of the calculator. If I press alpha and then the trace button, which gets me to function 4, I want to grab the y sub 2, which is the original equation, and then I want to make the input of that equation, I want it to be the inverse. So again, alpha and then trace, and here I want to put in y sub 3, which is option 3, and I'm just going to pick a value of 100 like I wrote here to the right. So put in 100, put in my 2 parentheses to close this off, and I'm expecting that my output should also be 100, and it is. And just to do this again with a different number, let me just arrow up, press enter, and then let's arrow back. Let's delete one number here, and let's change this to like I had 25. So when I press enter, we see that I'm also getting back 25. Alright, so that there was the check to prove that the inverse equation that we came up with is in fact true for this original rational function. Alright, that sums it up for this video. Please friend us on Facebook and also subscribe to that YouTube channel. And as always, thank you for watching.